For example, 2C, we're going to go ahead and find our P over Q's because that's generally how we start if we're not using a calculator here. And again, this is nice because Q is 1, and whenever Q is 1, it's really just the factors of P. So we get 1, 2, 3, 4, 6, 9, 12, 18, 36. Everybody agree? All right. So here's the thing. I have all positive numbers here. So if I plug in a positive number, it's impossible for me to get 0. But I also have all even powers. So when I plug in a negative number, what's going to happen? It's still all going to be positive. So are any of my rational roots going to work for this polynomial? No. And what that tells you is that you either have irrational roots or complex roots. Okay? So then that's going to create a problem. We have x to the 4th power, but we can't use synthetic division because we have no idea what the irrational roots are or what the imaginary roots are. So we're going to take a different approach to this. Now, what does this kind of almost look like? It is quartic, but what does it look like? It looks kind of like a quadratic, right? I have my first term is to the 4th power. My middle term is half of my leading term, just like x squared, and then x to the power of 1 is half of the first term. So we're actually going to solve this kind of like a quadratic. Now, if we do that, notice we have 3 terms, and if we wanted to try it, it almost looks like this is factorable, yes? Right? So we would think, well, what 2 numbers can multiply to 36 and add to 13? What is it again? 4 and 9, right? And then normally I would put x and x, but that's only going to get me an x squared. But what do I need to have instead? X squared and x squared. So then now we want to write this in factored form. I do have quadratic factors, but we want to have all of our linear factors. So we're going to find the zeros. What would you guys suggest doing from here then? And when we take the square root of both sides, what's going to happen? Plus or minus. And what's going to be left from when we simplify here? And then when we simplify here? Good. So how many zeros do we have right now then? We have all 4, and now we can write them in factored form. It's going to be x minus 2i, because that's our positive 2i factor. Our negative 2i is going to be x minus negative 2i, which is x plus 2i. And then we're going to repeat with the 3 i's. Okay. Now here's the other thing. So it looks quadratic, and we were really lucky here because it factored. But what if it didn't factor? What would you have to do? If we have a quadratic that we can't factor, what do? We do the quadratic formula. All right, now you guys don't have to write this down, but I want to walk you through it really quick just so you can see. All right, if we treated this like a quadratic, instead of saying x equals the quadratic formula, I would actually just say x squared equals the quadratic formula. Okay, because we would normally be solving for x, but in this case, because it's x to the 4th, it's really x squared that would end up getting solved for. So we would have the opposite of b plus or minus a square root of b squared minus 4 times a times c all over 2a, and that's negative 13 plus or minus a square root 4 times 36. Anybody? 144? That can't be. 244? 144? What was it? Ooh, but then, oh, it's x squared here. Oh, wouldn't I get 2 really answers then? Oh, no, the negative 13. Got it. I'm on it. All right. So you get negative 13 plus or minus a square root. What's 169 minus 44? 25. So negative 13 plus 5 over 2, negative 13 minus 5 over 2. And then you would get negative 8 over 2, which is negative 4. Here you get negative 18 over 2, which is negative 9. So then, once you get this, instead of saying x equals negative 4, x equals negative 9, it would be x squared equals negative 4, x squared equals negative 9, and then you're back up to here where we started, where you had your x squared equals negative 4, negative 9, and then you would go from there. Does that make sense? So you can solve this using the quadratic formula. It just works out that it's a lot easier when it's factorable. Okay, so next